Hello everyone, this video will be our first lesson on differentiation. Today we are going to start a new topic, that is differentiation. So now the topic differentiation comes under a larger topic which is called calculus in mathematics. Let me write it down here, calculus. Now what is calculus? If you ask me the informal meaning of calculus, then calculus actually means the study in mathematics, the study of infinite simals. Okay, that means small things. Okay, so calculus basically studies about small things in mathematics. Okay, now if you want to know the Greek meaning, the word calculus has been derived from a Greek word, and the Greek meaning of calculus, the word calculus, is small pebbles, stones, you may say small stones, used for counting. So something, so almost the same meaning in Greek as well, and then the same concept has been applied to mathematics. Okay, so the word calculus has been taken from Greek, which means small stones used for counting, and in mathematics it means the study of infinite simals. Okay, now under this topic calculus, actually we start calculus right from class 11, to be honest here. Okay, we have already started a little of calculus in class 11, but you may not be aware of it. The start of calculus, so you may say, will begin with limits. So there are actually three topics under the concept of calculus. Number one topic is limits. We have already done this in class 11. Number two is differentiation, that we are supposed to do today, differentiation. And finally, the last topic here under calculus is integration. So in fact, integration and differentiation, they are opposite to one another. Okay, so in the process of doing the sums that we will come across later, these two processes will be just opposite of one another. Okay, now integration we are going to discuss later, that is the later part of our syllabus. Integration is also in our syllabus. Limits we have already discussed. Integration we are going to discuss later. So right now today we are going to discuss differentiation. Now what is differentiation? Let's see, the definition is already written here. I want you to copy all this, whatever I have been writing here. So according to the definition, the rate of change of a value of a dependent variable with respect to a value of independent variable is called derivative of a function. So differentiation is the process of calculating the derivative. So this here right now you may see this is the definition of derivative, and the process of calculating a derivative is called differentiation. Remember, it deals with something that happens in an instant. So as you already know, it deals with something that happens in an infinitesimal change in time. Okay, so the rate of change of value of dependent variable with respect to an independent variable is called derivative of a function. So if you think about this concept, the rate of change, how to find rate of change, you know, you are aware of rate of change. Maybe in physics you have studied in class 10. Speed is also a rate of change of velocity, isn't it everyone? Rate of change of velocity. And you may say even acceleration is rate of change of speed. You're aware of that, isn't it? So we have come across this word rate of change, isn't it everyone? But try to recollect in class 10. Let me rub this. In class 10 we have studied something very, very interesting in the chapter equation of straight line, and that concept is the concept of slope. If you remember slope, what is a slope? So slope of a line, if you talk about slope of a line, there was two formula. The symbol for slope was m, and the formula for m was tan theta. One formula, it is the tangent of theta, where theta is the inclination, if you remember this. And the other concept was, I can also find slope by the formula y2 minus y1 divided by x2 minus x1 if there were 2 points and the line was joining these 2 points A and B, where A is x1 y1 the point and B was x2 and y2, isn't it everyone? Yes. So this was the slope of a line between 2 points. So if you look at this, even this is the rate of, can I say y2 minus y1 is the change of y, isn't it everyone? Even this one was change of y divided by change of x. Can I say that? Because y2 minus y1 means change of y and x2 minus x1 means the change of x. And in mathematics, changes are usually denoted by delta. So can I say delta y by delta x? Isn't it everyone? Yes. So the symbol delta is used for denoting changes. So the concept of slope also revolves around the rate of change. So it's something like rate of change, isn't it? Because slope is rate of change of y with respect to the rate of change of x, isn't it everyone? So from this concept of slope, we are going to slowly move towards the concept of differentiation, correct? Okay, so let us start. So once you have understood slope, now let me draw a graph. Let me draw a two axis here, the y axis and the x axis. Suppose if this is the y and the x axis, and let me draw a straight line here. If I draw a straight line here, and if I ask you, find the slope of this line, okay? Let us say this, the equation of this straight line is y equals to fx, okay? Then what I need to do is to find the slope of this line. I need to know the change of y and divided by the change of x, isn't it everyone? So let us take any 2 point. Let's say this is capital A. I have to take 2 points as a reference point, capital A and capital B. Let's say this point here is capital small letter A and this point here is small letter b. So at the point small letter a, the value of the function, so this is the fx and this is the x, isn't it everyone? So now y-axis is fx and x-axis is x. Now at the point a, what will be the value of fx? It will be fa by putting a instead of x. At the point b, what will be the value of the function? It will be fb. So can I say this point is, let me show you in different color, this point is a comma fa, isn't it everyone? And this point is b comma fb, correct? Okay, I'm putting it in curly bracket. Great. Now if you need to find the slope, then to find the slope between these two, slope of this line, what you need to do is you need to find the change of y between these 2 points and the change of x divided by the change of x between these 2 points. Let me show you with a different color now. Okay, by change of y, okay, let me join this. If I join this now, so isn't this the change of x between a and b? Check this out. Isn't this the change of x? Because b minus a will be the change of x. So that is delta x, or I can say this is delta x. And the change of y is, because this is fb and this is fa, what will be the change? So change will be this, isn't it? Delta y. So can I say this is delta y? So delta y will be, so the maximum value minus the minimum value here, isn't it? So can I write the change of y will be fb, sorry here, fb minus fa. That is the change of y, because everything is fb and from here to here is fa, isn't it? So this will be delta y, that will be fb minus fa, correct? Divided by, so everything here is b and till here is a. So what will be the change everyone? B minus a. So that will be b minus a. So that is the formula of slope of this particular line. Remember, it is a straight line. It is a straight line. Look at this. So its slope will be the same throughout. Whether you take a or b, any 2 points a and b here, whether you take these 2 points or whether you take points here, doesn't matter. Okay, you can take any 2 points in this line. Since it's a straight line, the slope of this line will be always the same. Okay. So this is the concept of slope with respect to a straight line. But what if I need to find the slope of a curve, not a straight line? Slope of a straight line is quite easy. We have done this in class 10. Now we talk about slope of a curve. This is where now things start to change a little. Okay, so let me now draw a curve. Let's say this is the x-axis, y-axis, and this is the x-axis. Okay, now let us say this. Okay, this is the curve that I am talking about. Okay, the curve is given by y equals to fx. So this side it is x, and this side you will plot fx, correct? The y-axis and the x-axis. Okay, now if you observe carefully, if you observe this curve carefully, then you know that the slope of this curve is not the same. Okay, since it is a curved line, check this out, since it is a curved line like this here, so the slope of this line isn't going to remain the same. Suppose because if I, okay, let me show you in a different color. If I talk about the slope here, okay, then since, as I'm saying, that the slope of this line is not uniform. For straight line the slope is uniform. Check this out, whatever is the slope here, same slope here, same slope, because by the way inclination will remain the same every time for a straight line, isn't it? So slope of this line isn't going to remain the same. The slope here, if you draw a tangent line here like this, see, this will be the slope of a line at this point A, and whereas at B the slope is more steeper, isn't it everyone? It's more steeper. Can you see this everyone if I draw a tangent line here? Whereas this side the slope is quite different here, because it will be the slope of this straight line. Okay, so since the slope of this curve is not uniform every time, it will keep on changing at every point I take here. See, you see that at A it's quite different, at B it's quite different, at C if I take, it will be very steep, almost vertical, isn't it? So this is the slope of the line at the point C. So it has a variable slope. The slope doesn't remain the same. So how do I conclude that for a curve I will not be able to find the slope, uniform slope for the curve. Instead, I will be able to find the slope of the curve at a particular point. If you ask me to find the slope of a point at a particular point A, then I'll be able to find. At B, I'll be able to find. At C, I'll be able to find. But the slope at A will not be equal to the slope of at B. The slope at C will not be equal to the slope at A, because the slope is different. So it is not possible to find one slope for the whole curve. We can find a slope at a particular point only. Is that clear? So that's what I'm trying to explain here. So now let me rub this and redraw the curve. Now we will take any one point and we will try to find the slope of the curve at any point A. Okay, so let me redraw this, and that's the curve. Okay, now since this is the curve, this is x, this is fx, this side and here. Now I know the formula of slope, everyone. What is the formula of slope? Slope will be delta y by delta x. That's the concept of slope. So let us say I want to find the slope of a point, slope of this curve at the point A. Slope of a curve at the point A. To find the slope of the curve at the point A, I need to find slope of this tangent line, which is only passing through one point, isn't it? So this, if I find the slope of this tangent line, then I'll be able to find the slope of this curve at the point A, isn't it? But the problem is, now I will not be able to find the slope of a line with one point A. So I will have to take another reference point B. So let us take another reference point B. So in that curve itself, I'm taking another reference point B, and let's join it. So if I join A and B, what do you call these type of line? This line is called a secant line. It's called a secant line. So I am getting a secant line. Okay, so remember, the slope of this line, green line, isn't the slope of the curve at the point A. Instead, I have to convert this secant line slowly into a tangent line, correct? So how to find the slope of this secant line? Now first let's discuss about how will you find the slope of this line. Let us say this point here, let me show you in different color. Let us say this point on the x-axis is small letter A, and okay, not A, sorry, X. Let us say it is X, and this point, let's say, is H away, H plus, okay, H more than X, H more than X. So what will be this? It will be X plus H, because I've told you this distance is H, correct? Okay, at the point X, what will be the value of fx? It will be simply fx. What about the value of fx at the point x plus h? It will be f of x plus h. Correct? Great. Now to find the slope of this green line, I need to do slope of this green line. I need to find the change of y. This is the change of y, delta y by delta x. This is delta x, isn't it? So what will be the change of y? As you know earlier, everything is f of x plus h. So it will be f of x plus h minus till here is fx. So you can see fx divided by this, everything will be x plus h minus x. So x and x gets cancelled. That will be f of x plus h minus fx divided by h. Correct? But now the problem is, now this expression that you are getting here, this is not giving me, this will not give me the slope of a straight line at the point A, because it is a secant line. Instead it is the slope of the line passing through A and B. And to find the slope of a curve, I need to find the slope of the tangent line. This was the line I was trying to find. Check this out. This was the line I was trying to find, the slope of the line. But right now I've got this line here. See, so this was B. Right now I've got this. So what do I need to do? What do I need to do to convert this line, to slowly bring this line, this green line, to, let's say, to make this green line, let me do in blue. So to make this green line into a blue line here slowly. Okay, so what do I need to do to bring it down? So for that, what do you need to do is understand properly. You have to slowly bring down this B, slowly make it the B closer and closer and closer. That means first of all you have taken A here and B a little far. So take another point B more close, take another point B more close, more close, more close, more close, and finally when you take infinitely close, 2 points infinitely close to A, then you will be able to get the slope of that line. But that way, when you do that, check this out, it's becoming a little messy here. When you do that, this distance will become smaller and smaller and smaller and smaller. Did you see that this distance is becoming smaller and smaller and smaller and smaller? Okay, so that means basically if I want to find the slope of a tangent line at the point A, I have to make h smaller and smaller and smaller. So for that I use the concept of limit, you know that. So I write limit h tends to 0 f of x plus h minus fx divided by h, because that way h will become smaller and smaller and smaller, and finally this green line will become a tangent line. The figure was quite messy, so I had to make a new figure and explain it again here. So basically what happened there was the green line, what happened, I took right now the value of you may say A is x and this was x plus h, isn't it? So what I'll do is I'll reduce this distance so that slowly this B comes here, it will get reduced, another B, it comes here, this distance gets reduced. Check this out, another B, another B, another B, and another B here. So ultimately when 2 points are almost the same, then I will get that blue line, that tangent that I'm talking about. Remember this tangent. So this tangent will give me the slope of the curve at this point, because this angle theta is the inclination of this tangent line, isn't it everyone? Yes, if you see this, at every point when I draw a tangent line, the value of theta is changing. Here it's different theta, here it's different angle, here it's different angle. Since the tangent makes different angle at different points, that's why the slope of this curve is also different at different points. Are you understanding it? Basically, let me show with the help of a circle. What did I do? I took 2 points A and B and made a secant line like this. Okay, then slowly I brought the B closer and closer to A, and like this, another one like this, another one like this, another one here, another one here, and finally it comes here and it becomes a tangent. Did you see that everyone? So this is how the concept of derivative works here. That is what I have done. That's why I need to make this h smaller and smaller and smaller. So when limit h tends to 0, f of x plus h minus fx divided by h, when h becomes smaller and smaller and smaller, you know the concept h tends to 0 means h will become smaller and smaller and smaller. When this happens, then I get the slope of the line at the point A. So this formula that you have just obtained, this limit that you have just obtained is called the derivative. What is this called, everyone? Derivative, and it is denoted by dy by dx. So dy by dx. So I know the formula. Let me write here up here. So what is dy by dx? The formula of derivative. The formula of derivative is limit h tends to 0 f of x plus h minus fx divided by h. This will be for any function fx. So finally, using the concept of slope, we have derived the formula of derivative, or derived the formula of derivative, and the process of finding this derivative is called differentiation. So basically, according to the definition, differentiation is the rate of change of dependent variable with respect to the rate of change of independent variable. And in the formula that we have just obtained, we have obtained the change in y with respect to a very small change in x, given by the formula dy by dx. And that way we can also say derivative is the study of infinitesimals, because in the process of obtaining the slope of the tangent at the point A, we reduced the value of h, which was the change in x, to very small quantity by saying h tends to 0. So finally it becomes infinitesimally small, and then we get the value of dy by dx, that is the slope of the tangent at the point A. Now we are going to derive a few formula using this first principle. This is also known as first principle, by the way. This is also known as first principle of derivative of differentiation. Remember, okay? So first principle of differentiation or derivative. Using this formula, we are going to derive the standard formula on derivative. Your syllabus in class 12 is to just learn the standard formula. Actually, all this explanation is just to make the chapter interesting. You will be given a set of standard differentiation formulas. Using that, you will have to differentiate. But where does those standard formula comes from? From this formula of derivative that we have just obtained. Check this out. This is the formula of derivative that we have just obtained. So I will derive a few formulas for standard derivatives using this formula. Then we'll directly go to the standard ones. Here I have one example of how to use the first principle to find the derivative. So it says fx is x square. You need to find dy by dx using the first principle. Okay, so we know dy by dx. What's the formula? Dy by dx we just obtained was limit h tends to 0 f of x plus h minus fx divided by h. So here fx equals to x square. So what will be f of x plus h? So what happens if I replace x by x plus h? It will become x plus h whole square, isn't it, everyone? Time to put the value. Therefore dy by dx will be limit h tends to 0. F of x plus h means this one. So I'll replace x plus h whole square minus fx means, what is fx? Fx is x square, so x square divided by h. That gives me dy by dx equals to limit h tends to 0 x square plus 2hx plus h square minus x square, isn't it? Using the formula a plus b whole square, then h. So x square and x square gets cancelled. Then I'll do it up here. Limit h tends to 0. I have 2hx plus h square divided by h. I can take out common, h common, so 2x plus h divided by h, because until and unless I cancel this h, otherwise if I put the value of h 0, this will become undefined divided by 0, isn't it? So I'll cancel it. Finally, limit h tends to 0, 2x plus h. Time to put the value, direct substitution limit. So what do you get? So that's 2 into x plus 0. So the answer is 2x. So here I have the formula. So I have derived this. So if you ever come across ddx of x square, if you ever have to do ddx of x square, what's the derivative of x square? Then you can directly say it is equals to what, everyone? 2x, because I have just obtained 2x. One more sum based on the first principle, just to give you an idea about how the first principle works. Actually, the first principle is not in your syllabus. You need to differentiate the function not using the first principle, instead using the standard derivatives that we are going to discuss in the next chapter lessons to come. Okay, so if fx equals to sine theta, find dy by dx. So let's start. Given fx equals to sine of x. Let's say this is sine x, okay, not theta. Let's say, sorry, let's say this is sine of x. Now f of x plus h will be equals to sine of x plus h, isn't it? Replacing x by x plus h. Therefore dy by dx equals to, everyone knows, limit h tends to 0, f of x plus h minus fx divided by h. So that gives me limit h tends to 0, f of x plus h is sine x plus h minus sine x. Here I have, and divided by h, because fx means sine x, correct? Now, so here now you need to use a formula. If you remember the formula sine a minus sine b. That's in class 11, sine cos cos sine cos cos sine sine, that type of formula we had derived last time. So the formula is 2 cos a plus b by 2 sine a minus b by 2, if you remember this. Okay, you can just check this formula in your formula copy. So let's put it here, and that gives me a limit h tends to 0. This acts as a and this acts as b for me here. So it'll be 2 cos x plus h plus x divided by 2. That's the first one. And sine, I have x plus h minus x divided by 2, and denominator I have h, correct? So I have 2 outside. Limit h tends to 0. Here I get cos. I get cos. Let me write like this. Cos. Okay. Get cos 2x plus h divided by 2, and here I'm getting sine, let me cancel this, h by 2 and whole divided by h. So you need to have a little knowledge about limits here to evaluate this. So how would you evaluate this? Now let me do it here. To evaluate this, I have 2 limit h tends to 0 cos 2x plus h divided by 2. And look here carefully now. So then I'm left with sine h by 2. If you remember in class 11, if there is a h by 2, it's better to have h by 2 here as well. Yes, but I need to neutralize its effect. So I need to also multiply it by 2, so that this 2 and this 2 gets cancelled, isn't it? So basically, let me rub this side. Okay, now what I can do is twice divided by 2, this 2 comes right out here, cancels. Limit h tends to 0, cos 2x plus h by 2 into limit, I can write, the limit gets distributed, in the other one as well. So that gives me h by 2 tends to 0, sine h by 2 divided by h by 2. Okay, the reason, as h tends to 0, h by 2 tends to 0. By the way, if you remember, in class 11 we have done limit x tends to 0, sine x by x divide x equals to 1. So if limit this becomes sine h by 2 and h by 2, then until and unless this is h by 2 equals to 0, then this will also be equals to 1. This 3 has to be same, isn't it, everyone? Yes. So I can write instead of this 1 in the next step. So limit h tends to 0, cos 2x plus h divided by 2 into 1. So no need to write that, it's okay. Now limit, let's put the value now. Cos 2x plus 0 divided by 2, putting the value of h as 0, that gives me cos 2x by 2 cancels, and I get cos x. So here I got the second formula, so I will write it down up here. Therefore, if you ever get dx of sine x, then what is the formula of dx of sine x? It is supposed to be cos x, correct? So this is another standard formula. So I have just done 2. There are many standard formulas, 20 to 23. So I have attached those standard formulas below as a PDF file. I want you to copy it in your notebook. So in the next class, we are ready to solve sums based on differentiation.